All right, thanks everybody. So Anne's research is awesome. I work a bit with Anne on hers, and she works a lot on mine. So she's been instrumental, and as well as our two daughters, in getting our work done on this project. So we have a little bit more interesting things to show you this year. Which wait, how do I move slides? Here we go. There, it's going. It was a very busy year last summer. We got in quite a bit earlier in the season, installed the in-pond, the mesocosms that, I don't know if you recall, they're the cells that we put into the ponds, and we had a bunch of different treatments. We'll go and get into that in a minute. We had a pre-pond swale installed, so everything was set up fairly early. So we were able to do a full season of monitoring. There's ongoing data analysis, obviously, a bunch of new data coming in. The technical report and TAC meeting are to come. The video is in progress, my project ends in December of this year. So I have a little bit more time to finish up everything. But essentially, this was my last kick at the can to see if I could get something a little more interesting in terms of data. And the mesocosms certainly presented a challenge. So it's first go through the data from 2020. Was really not encouraging. We did a lot of things differently this past season to try to make them more effective. We saw some differences, but it's really hard to interpret the data. We're not sure if the volumes are just too small. They're somewhere between 1 meter and 3 meters cubed volume. And we know other places, there's a wonderful big study in Europe. They have this great big lake and huge cells. So it's difficult to find a control. We're not sure if the way the mesocosms, we had to sink them down. We had all kinds of issues with flooding and extra water this year compared to 2020, where we had drought. So we don't know if it was sitting on the bottom and changed the conditions at the bottom too much, made it more anaerobic. So we're not 100% sure if this were ideal, but as we get through some of the more in-depth analysis, maybe we'll see something a little more valuable. There was just so much data that's pretty much how I felt. Overwhelmed at times. I think annually I have a nervous breakdown when it comes to the data because there's just so much and I'm not always sure how to tackle it. And then Anne calms me down and we start going through it and get somewhere with it. So I went back to the basics of what are we doing here? What are the drivers between poor pond quality? So what are the things that make blooms happen, that create issues in ponds and that eventually affect farms and their ability to use that water? So the key to our nutrient availability and light that we have some influence over. Temperature, we certainly don't have a lot, and the redox potential, we don't have as much control, but maybe we can do something about the first two. So that's really what the focus of the project was. So through last summer, we said, what do we need to do? We did more replicates. We did a lot more biology diagnostics. We had originally sampled just at the surface, and it's very difficult to get deeper samples. So we used a sludge judge and went right down and took a whole column sample to try to get a better picture. The ponds are some of the ponds get to be about 12 feet deep, but they don't seem to stratify. I think there's a lot of flow through these ponds. Some of them are more shallow, so they don't stratify. So I think the whole column sample does give us some information. we have YSI data, our multi-parameter meters with oxygen and so on. So and temperature. So we do know some differences between top and bottom. We do see a bit, but I don't think there's a true stratification layer. We tried some more treatments. We did bacterial applications. They were very expensive. I don't know that they're completely realistic for long-term big pond management, but we said, go big or go home, this year. That was our last kick at it. And we really wanted to try something that might be dealing with it, because we knew from last year most of the ponds, the water samples that we're getting back, the grab water samples, had really low nutrient levels, maybe enough to cause a bloom, but still quite low. And in most farms sending their samples in would get in less than detectable levels. We ask for low detection limits on our analyses, but most farms would see nothing really. And so where's the issue? And we felt it had to do with sediment loading, and that's where we spent a bit more focus this year. And again, we started a pre-pond swale installation of the hybrid treatment system last year, and so that was installed for this past summer. So we had a whole range of treatments, and that some of them are repeats, and we did do more replicates. And then again, we did the bacteria treatments for looking at microbial degradation, a decomposition of sediment, and phosphorus binding compounds at Clarifos as sort of new pieces for this year. So some of our ponds, I just want to talk quickly about them. This is site B. I'll just whip through these. This is a fairly small pond. It's very shallow. It's lovely and green. It had a significant amount of blooms, and I'll give you some sense of the population of what's in these ponds, all the work that Anne did in the diagnostics later on, but just so you can get a picture in your mind. And there's some ponded area at the outlet there, right in the middle in the background here. And this we had 2 floating docks at this same pond, and there were 10 mesocosms. So if you remember, these are the cells I'm talking about. We aerated all of them except for the control, because at this site we focused primarily on the bacterial and the Clarifos, the phosphorus binding agents, and so we wanted to make sure that the volume within that cell was fully aerated and turbulent. We didn't want them to be sitting stagnant. I think the idea behind these compounds is and mixes is that you put them in and you get good activity when you keep agitating the water. So then we did that, and way off to the upper right, there's a little black line there, and that's a partition. So this whole pond is only about 700 meters cubed of water, and this is about 40 of it. So we separated the portion off to the left here, sort of the north corner, using a wall of that material that we used for the mesocosms. And you can actually, it did work. We had an aerator going on the left side, and the water quality appeared to be a little bit different, and you could see scum and so on coming up against it. That was from the main pond. So I think we had an interesting, tried to do a larger scale application of the bacterial product there. Site C at their H pond, looks the same kind of green, but it's very different. So when you're actually there and looking, most of this green that you see is duckweed. So there's a huge amount of lemna. We could not get duckweed out of these cells. I mean, it was next to impossible. So we had a control cell. We had a duckweed, which you can see here, and on the left is nice and green with the layer growing very well. The control was right at the end, and very. This was the first one here is macrophytes. We put chara in, which was extremely stinky and a horrible skunk, worse than skunk smell. And it really didn't grow, but there's control at the end. We tried to keep it clear. This is the covered. We had a complete cover shading and a very well aerated cell that had a solar panel connected for power here, and we had a nice pump going. So this aeration was extremely effective this year. So we may have seen some differences going on here, but it's quite a deep pond and extraordinarily clear. So great Secchi depths, and we'll have a look at that. And this pond was last year drought, complete drought, and we lost everything. This year we said, okay, we're going to put all the floating islands in one channel, and everything overflowed the banks. It was just so much water. They've changed the flow, but this pond is quite narrow and long, and it gets a lot of inputs from field runoff as well. And so there's some fertilizer coming in here. Bit of an angle here, but just the angle I took the shot. I was showing this is a fairly new pond at Site D, only a few years old, and there's some container nursery runoff into this pond. And this one was the one last year we highlighted, had some significant nutrient inputs, and yet it was fairly clean. But you can see in this past season, things may be changing. And at this site, they've actually started funneling all of their container runoff through this new, basically it's a hybrid treatment system with wood chips in the front, slag in the middle, right at this center line, and then gravel at the end. It's fairly shallow, but we were hopeful that we would be able to see some data from that. And our final site, which they had a nanobubbler sonification installed, and we actually have our little mesocosms, 3 of them set up one way off on the left to be the controls. And then they added water hyacinths in this season to work on it. So we had some very serious blooms here in the past. And so we were curious to see how things would look this year. So getting into some of the data, just as a reminder, some very similar, some of these numbers to what we saw last year. So I'm just showing an average value here with some of the ranges and brackets. And so the different pond sites, we have 5 main sites with ponds. And so total phosphorus, quite low. Up to 0.3 is really totally acceptable to the ministry, but it's obviously enough. There's still some loading here of total phosphorus. So there's runoff sometimes from yards or fields as well as container, and the portion of soluble reactive is quite low in comparison in most cases, except if you look down at pond D and E. D has a lot of, still had, especially in the beginning of the year, had some, before they installed the treatment swale was fully functional. There's fertilizer runoff going in there. And E has a long history of having, there's no nutrient loading going in now. It's only precipitation, but there's certainly a lot of history at that site. Nitrate quite low from the most part, but again, this CL pond had some outdoor runoff and ammonia quite low, but I thought it'd be interesting to share that. But overall, as I said, a farm won't see have a big concern here when they get these results. They're under the 0.3 limit for total phosphorus, the nitrates under 10, and so for the most part, they're not going to have a concern when they look at this data. Going back to the basics, what are we looking at? We're looking at pond nutrient cycling, where if the water quality that they see is quite low, then what's happening, right? We're looking at quite low detection limits, so we get to see some of the actual numbers that are there. But we've got the internal cycling happening within the pond that's moving nutrients up and accessing nutrients out of the sediment. So this is critical. And we also have an inoculum there, right? We've got algal population and cyanobacterial populations that can overwinter and can access these nutrients out of the sediment. So I said to Anne the other day, I think we got to my gut tells me it's all about the sediment, right? So, and what's happening in the cycling of these nutrients. And so how are we dealing with that? And that's really where a lot of those treatments that we came up with were chosen, was based on that direction. So if we add to, this is the top part you've seen, and if we add to that, it's just critical now that we start thinking about using the YSI data, so the multiparameter meter, and looking at chlorophyll A and phycocyanin for green and blue-green, pigmentation, looking at turbidity, looking at Secchi depth, as another way of looking at clarity, looking at the oxygen levels. And then we start to really see some interesting numbers. I mean, we've got the best water clarity in this H pond at site C. Very low turbidity compared to some of the other sites, and their chlorophyll numbers and phycocyanin numbers are quite low, and that's mostly chlorophyll, by the way. There's a lot of macrophytes there, and it's there's a lot of I think we'll talk about it, but there's some brown algae or golden algae, and but no blooms at this particular one. Whereas site B, we definitely saw blooms. And if you look, we've got much higher numbers, going up to 277 in some cases, which is very high turbidity. Look at 200, like it's a magnitude greater than the other sites, and very poor Secchi depths. So, I mean, the water's only 0.5 meter deep, granted, but it's pretty clear that there's some issues with site B and their water quality there. So this is where the data starts to show you something different for these ponds, right? If you look at the nutrient data that comes out really between ponds, you wouldn't really see that there could be an issue at one pond over another, but using the right tools to look for the issues. I think that's what we really found last year and in 2020, and started to focus on much more in 2021 season. And we look at pond sediments, and you look at how much phosphorus is in there. Like, there's a lot of phosphorus. So definitely there's a place to access nutrients if you've got the right biology to make that happen. And certainly we know that some of the algae and bacteria and cyanobacteria are capable of accessing nutrients out of the sediment. So there's a wonderful opportunity for them there in all of these sites. But again, some of the sites had blooms and some didn't. So why not? What's the difference? So after this, there'll be a quiz. I'm going to finish early, so there's a quiz. You have to name all the different genera here that Anne identified. You can't really read any of this, but I think I just want you to step back and just let your eyes blur. And this upper left, what's overwhelming is how much of this cyan color you're seeing, this bluey, this greeny color. So this is when Anne has identified blue-green, so a cyanobacteria, and then we've got the different algal types, in the golds and the browns and so on. And see how much greeny blue is in here, right? So that's site B that got the blooms. And then we have H pond at site C, did not have a bloom. There is no cyanobacteria at the site. So then we started saying, okay, well, we looked at some of the correlations that we had done from 2020 data. Oh, look at this. Okay, so site B, we summed the two together, the chlorophyll and phycocyanin, compared it to temperature, to ODO, started looking at some options. So this is just a sampling of some of the data. Quite an interesting range here, and look at how much more chlorophyll and phycocyanin we have in this pond. And I'd love to do some cluster work here and see where this is happening. And the comparison here is quite interesting, less than 10 ODO and less than 100 some of these pigments. So really interesting that this portion of the graph looks really different. Now, it's not quite as exciting for the other sites, but I try to get a sense of, we're still exploring with this data. This is the Owl Pond from Site C, and possibly a little bit of blue-green showing up in there, but generally really beautiful, nice looking, healthy site. Remember, it does have inputs from the field and as well as some container input, and it's a little bit different site. This is where we put the phyto links. And so the different treatment cells are listed here, but again, it's more just get a general picture of the overall color that you're seeing there. And maybe this correlation is not quite as helpful, but maybe it is. It's still looking quite tight in this bottom quadrant. This is site E. I'm going to skip ahead one. We get the 2020 data as a comparison. Lots of blue greens, 2021, lots of blue greens, but some other things happening. And interestingly, further down in the year, getting towards September, late August, September, October, we're getting quite a bit more in the algal capacity, not in the blue greens, like a lot less. And so I don't know if this is as a result of the water hyacinths that you would have to be very careful where you use these and where you choose to plant these, because that's me with a shovel. We had to use, Anne and I used shovels to actually create a path through this so we could get to our sites, and to find the mesocosm was like, where's Waldo? It was really challenging. So maybe this covering at the end of the season really had an impact. So we have a lot more to do here. There's a little bit of a stretch here, a little change in the shape of this cluster of data. So it's worth exploring. I'm not sure if we got all the answers right here, but this is just our starting point. And site D, I broke it up into this first year 2020 data. Really, it was a fairly new pond at that point. And I love Anne's notes, very little of anything. And then we had brown flagellate algae and, double star. So that means quite a few. And then in 2021, look at this. All of a sudden we have this change. So we do know that they have a new pond. Conditions were quite good, but we also know that this is the pond that had a lot of loading from the container, and then they are the ones that decided to put the treatment cell in. So I think I'm going to run out of time shortly, so I'll whip through these last ones. But we don't have as much data here, but there may be some interesting things happening in this pond. So this is where we put in that treatment cell system. So what did it do for us? Actually, I think it needs it needs some repairs. It needs a little bit of tweaking, but it is doing something. There's a lot of dissolved reactive phosphorus coming in from the fertilizer on the influent. This is the drain right off of the container beds, going through the cell, wood chips, then slag and gravel. So it's removing phosphorus, and it's doing a great job at removing nitrate. So ammonia is pretty low anyway, but the nitrate is really strong, obviously coming in through the fertilizer, and it's being removed by the wood chip system. So we might need to do some tweaking to add some more slag, see if we can address that phosphorus a bit more, but it is doing something. So that's really quite exciting. So hopefully their pond quality improves with this. So where does this leave us? I think we're still looking, I think we're on the right track. We do have to think about potential for covering ponds, whether it's a physical cover or we're using plant material. I think limiting light is useful. I think there are options for limiting nutrient supply. That pre-pond removal system, looking at HTS or some other concepts would be very helpful. Dredging may be valuable. Looking at BMPs, looking at tweaking fertilizer, control release coatings, etc. I also think the mesocosms are tricky. I'm not sure that they didn't work. I'm not sure we gave them enough time. So, these things, sediment is not going to be fixed in a month. Or a season even, these are long-term issues. And so if we're measuring the right things and we're doing the right things, maybe 5-10 years, I don't know. We need a big project, but I think that we do have the tools to actually look at and understand what's happening with these ponds and how to actually address it. So I'm kind of excited about that, much happier than I felt when I first looked at the data. So next year, this coming season is a big year with a lot of data, and we'll obviously try to do whatever KTT we can. And if anybody knows of this perfect site with 2 matching ponds where we could split the influent, that'd be amazing. I'd love to try some things. And that's it for me. So thanks again to the farms, particularly Anne at Soil Resource Group, and all the contributors, as well as to AAFC and the COHA cluster group. So thanks again.